Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is dehydration of alcohols, specifically how the exact same starting alcohol can form either an alkene or an ether, depending entirely on reaction conditions. Let's begin. When an alcohol is heated with concentrated sulfuric acid at genuinely high temperature, around 170 degrees Celsius, for ethanol specifically, it undergoes intramolecular dehydration, losing a water molecule from within that single alcohol molecule itself to form an alkene. The mechanism proceeds through protonation of the hydroxyl oxygen by the acid, followed by loss of water to form a carbocation intermediate, and finally loss of a proton from an adjacent carbon to form the carbon-carbon double bond. For alcohols that can form more than one possible alkene product, Zaitsev's rule applies: the genuinely more substituted, more stable alkene, the one with more alkyl pripsyrally attached to the double bond carbons, forms as the major product, since the reaction proceeds through a carbocation intermediate whose own stability directly favors that more substituted elimination pathway. At a genuinely lower temperature, around 140 degrees Celsius, for ethanol, using the exact same concentrated sulfuric acid, the reaction instead proceeds through intermolecular dehydration. Two separate alcohol molecules combine together, losing one water molecule between them, to form an ether. This is precisely a nucleophilic substitution. One protonated alcohol molecule acts as the actual leaving group, while a second, entirely separate, unprotonated alcohol molecule acts as the nucleophile, attacking directly at the electrophilic carbon that's losing water. This specific temperature dependence, 140 degrees favoring ether formation, 170 degrees favoring alkene formation, for ethanol specifically, is genuinely the single most tested numerical detail in this entire topic, and it's worth memorizing these two exact reference temperatures directly. The single most important recognition skill here is genuinely just temperature. The exact same alcohol treated with the exact same acid gives completely different products purely based on reaction temperature. This is a genuinely favorite G trap. Testing whether students actually notice and correctly apply this specific temperature dependence rather than just assuming a single fixed product. A second trap involves the underlying mechanism type. Alkene formation proceeds through elimination, while ether formation proceeds through substitution, and confusing which specific mechanism applies to which specific product is a common genuinely costly error. Also remember that ether formation genuinely only works well for primary alcohols, since secondary and tertiary alcohols tend to favor elimination to the alkene even at lower temperatures, because their own more stable carbocation intermediates form considerably more readily. Let's recap. Alcohols dehydrate with concentrated sulfuric acid, and the product depends entirely on temperature. Around 140 degrees, for ethanol, gives an ether through intermolecular substitution, while around 170 degrees gives an alkene through intramolecular elimination, following Zaitsev's rule. For the major product, ether formation works best for primary alcohols, while secondary and tertiary alcohols favor alkene formation even at lower temperatures due to their more stable carbocation intermediates. That's dehydration of alcohols to alkenes and ethers. Keep the two reference temperatures for ethanol sharp. They're the fastest way to nail this topic's numericals. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.